Hello everybody. In the last class we had seen if a Boolean function is given, how to convert it to how to get a truth table out of it, and we also saw how to implement a Boolean function and how Boolean algebra can be used to simplify a Boolean expression and get a minimized expression out of it. And we also discussed Shannon's expansion theorem, and in today's class we shall discuss the canonical representation of a truth table using Minterms and also as using Maxterms, and we shall discuss given a canonical representation how we can get a two level implementation of it, and also in side by side we shall discuss multi level implementation, and we shall end with positive and negative logic. So, the last class we ended with the nested version of Shannon's expansion theorem, and we arrived at for a two variable problem an expression f x plus y. We just took this as an example. So, we can may not look at it at this point of time. So, this is the truth table, and this particular truth table we can see that there are 4 such terms, and the terms that are associated with 1 from the Shannon's expansion theorem, if we just compare these are the terms, okay, and this was there in the final expression that we had formed. So, these are called product terms, okay, and which is finally summed, okay, the AND terms which is finally ORed. Okay. So, interesting thing is here that only the one that are having function output 1 which is considered in this summation process or ORing process. The one that is having 0 is excluded. Okay. And another interesting thing is if you look at the xy combination. So, when x and y both are 0, right. So, the corresponding term is x prime and y prime, okay. And 0 1, if x is equal to 0, this is x prime, and y, this is just y uncomplemented version that we find. So, x is 1 and y is 0, this is x y prime, and both of them are 1, both are uncomplemented. So, these are the corresponding term that we get which is called also Minterm, okay, in this two variable problem. So, this Minterm is means Minterm or fundamental product or some standard product is nothing but a product term containing all variables, okay. So, this x over here is not a Minterm, right, but x prime y, this is a Minterm because it contains all the variables. It could be in complemented version or uncomplemented version, primed or unprimed, okay, it does not matter, but these are there. So, we can see that for each of for this two variable problem, 4 possible such Minterms are there, this x prime y, x y prime and x y. And what we do, we just for convenience, we term them also using M0, M1, M2, M3. This suffix 0, 1, 2, 3 comes from their decimal equivalent of this xy values. So, 0, 0, the decimal equivalent we know is 0, 0, 1 is 1, 1, 0 is 1, and 1, 1 is 1, 0 is 2, and 1, 1 is 3. So, that is why M0, M1, M2, M3, that is how it is mentioned. And finally, the function is obtained by taking OR of all the Minterms, okay, that has got 1 in the function output that we have, that we notice here. Okay. So, that was a 2 variable example. For a 3 variable, what we will do? So, we shall have the corresponding Minterms. The Minterms will be having all the 3 variables, and the possibilities are 8 with 3 variables. So, 0, 0, 0, okay, for this combination at the input. So, the Minterm will be x prime, y prime, z prime, all of them. Wherever 0 is there, the corresponding term will be primed. 0, 0, 1, it is x prime, y prime, z, because z is equal to 1. So, z is unprimed or uncomplemented. So, that way we will go up to when all of them are 1, it is x, y, z, okay. And the corresponding notation in terms of M0, M1, M2, it will go up to M7, which is the decimal equivalent of this place, okay. So, we already have noted that the binary equivalent of 1 1 1 is this place value is 4, okay, and this place value is 2, this place value is 1. So, if it is multiplied with 1, 2 and 4 here each of these cases. So, 4 plus 2 plus 1 is your 7. In this case 4 plus 2. So, this is 4, this is plus 2 and this is 0 multiplied with 1. So, it is 6. So, this is M6. Okay. So, this is the way we get the decimal equivalent and the corresponding notation is presented here. Okay. And if we look at this particular truth table, okay, this truth table we have seen before, but here just we are looking at given a truth table how we are converting it to a corresponding Boolean expression. Here we are talking about expression that has got minterms. Okay. So, we shall look at the terms that are having all ones. So, these are the terms that are having ones 1, 2, 3, 4, 5. So, 5 minterms will be there and which will be summed to get the corresponding Boolean expression, right. So, this is the one where the first term x is 0, y and z are 1, okay, for which the minterm is generated. So, this is x prime because it is 0 and y z. So, x prime y z that you see. Next one is x is equal to 1. So, it will be x, then y is 0 and z is 0. So, y prime z prime. So, x y prime z prime. So, this way you will get all the 5 terms and these 5 terms you can see M3, M4, M5, M6 and M7, that is what you do here, and you can use for a more compact representation a sigma, a summation sign where M stands for min term, the small m and 3, 4, 5, 6, 7. So, these are the corresponding decimal equivalent places, that is what you finally sum it up, and is called canonical form, right. And you can have a normal SOP form also, which is just as I said x plus y z, that is not called canonical form. When all the variables are present in you are summing up the minterms, it is called canonical form representation. So, this was a sum of product kind of representation of the truth table, and you can have a product of sum, okay, the dual version of it. So, for that the term that are used are called Maxterm. Okay. So, in how these Maxterms are formed and designated. So, again if you go by the dual of the Shannon's expansion theorem, the one that we had. Okay. So, if you expand the function that we had earlier, this one that we just used. So, if you for this particular truth table, if you keep expanding it x plus x prime y, right, and then you know all the individual terms and you substitute it over here. Only we know that f 0 0 was 0 and rest of the terms was 1 by calculation, and then when you do it all individual terms will generate 1 and only the last term will generate 0. So, 0 plus x plus y and rest of the terms are all 1. Okay. So, that gives you x plus y. So, this is you are getting from nested version of Shannon's expansion theorem, this dual version. Okay. So, that you can see, and the corresponding in the truth table, this corresponds to only one location, that is 0, and for the Maxterm definition, wherever there is a 0, we take it as uncomplemented, okay, unprimed, and whenever there is a 1, we take it as complemented. So, this is the difference, important difference we have to take note of between minterm and Maxterm designation. And of course, this is a sum term. So, there is a or sign in between two variables. In the other case, there was a and sign, okay, product sign between two variables. So, this is the important difference. So, we see that for two variable, these are the 4 possible cases where all the literals, all the variables are there, and the terms are 0 0 x plus y, 0 1 x plus y prime, 1 0 x prime plus y. Because it is 1, it is x prime, x is 1, that is why it is x prime, y is 0, that is why it is y. Okay. 1 1, this is x prime plus y prime. If it is 1, as I said, it will be primed, and if it is 0, it will be unprimed. Okay. So, coming to the definition, so some terms containing all variables of a function which is there in a particular n variable problem. So, that is called fundamental sum or standard sum or Maxterm. Okay. And similar to Minterms, we also designate it with M0, M1, M2 and M3, where 0, 1, 2, 3 corresponding decimal equivalent. So, 0, 0 this is M0, this is M1 and so on and so forth. Okay. This capital M represents Maxterm, small m we have used for Minterm. Okay. And final expression we get for this particular truth table just by taking product of taking AND of all the Maxterms, okay, that we have got for a particular function, where each the function output containing 0 generates that particular combination of the input generates a specific Maxterm. Clear? So, we look at it for 3 variable example. Okay. So, this x, y, z all of them 0. So, if it is 0 then it will be unprimed, uncomplemented. So, the corresponding Maxterm is x plus y plus z. Okay. 0, 0, 1 it is x, y and z is 1. So, that way z prime will be there. So, x plus y plus z prime. And that way when it is 1, 1, 1 we have got x prime plus y prime plus z prime. So, this is 3 variable, you can extend it to n variable, and the location wise. So, this x 0, 0, 0 is decimal equivalent is 0, 0, 0, 1 decimal equivalent is 1, 0, 1, 0 decimal equivalent is 2. So, you have got Maxterms M0, M1, M2 up to M7. Okay. For the same truth table that we had seen before, okay, if you remember the same truth table, we had 5 ones here, right, and the Minterms contained 3, 4, 5, 6, 7. Now, we are trying to represent it using Maxterm. So, the Maxterms that are there which need to be considered are the places where there are zeros. Okay. So, 3 zeros are there, 3 Maxterm will be there which will be finally ANDed. So, we have to see that how these each Maxterm is represented. So, 0, 0, 0 these are the 3 different values of x, y, z for the first Maxterm over here M0. So, this is nothing but your x plus y plus z, x plus y plus z. So, that goes here. So, next one x plus y plus z prime and third one is x plus y prime plus z. Is it okay? So, this is your M0, M1 and M2, and more compact representation, this is the product pi, that means that multiplication of Maxterms 0, 1, 2, that is ending of 0, 1 and 2, 3 Maxterms. Okay. Is it clear? Okay. So, this is also called canonical representation because all the variables, all the Maxterms are involved. Now, given one particular form, can we get the other form out of it? So, the examples we have seen, in the first example we had seen that 3 ones were there and 1 0 was there, and for Minterm based representation SOP, this is what we got. Okay. And for Maxterm based representation only one term was there, so that is why we can just write it, we can remove the pi, thus it is M0. Okay. So, if you see that there are 4 possible terms in the terms of decimal equivalent 0, 1, 2, 3. So, if 3 goes here, the remaining one out of the whole set is there in the other case. So, if Minterm contains 1, 2, 3, Maxterm will contain 0. Okay. In the next example, we have seen the Minterm contains 3, 4, 5, 6, 7 and Maxterm contains 0, 1, 2. So, for 3 variable problem, possibilities are 0 to 7, 8 possibilities. So, if 5 is taken there in Minterm based representation SOP, so rest 3 is remaining 3 is taken up in the Maxterm based representation using POS form, product of sum form. Okay. So, the whole set minus one particular form representation, whatever are the corresponding decimal equivalent places, then remaining is going for the other form. So, that is the way we can quickly convert from one form to another. Okay. The other important thing that we can observe from whatever discussion we had so far is in the first example second example, the f x y z. So, the min terms were 3, 4, 5, 6, 7. So, if you take complement of x y z, whatever we had, okay. So, wherever 0 was there, 1 will be present, and wherever 1 was there, 0 will be present. Okay. So, f prime x y z, that is complement of x y z, the one that we had, will be having min terms 0, 1, 2. So, this in the SOP form, summation of these 3 min terms, that would be giving you the complement of f x y z, the way you have defined in the truth table. So, you can write it in this way, m 0 plus m 1 plus m 2. Okay. So, how can we get f x y z from f prime x y z? We just take complement of it, right. If you take complement of f prime x y z, that is double inversion is the same the function itself. So, that is what is that, m 0 plus m 1 plus m 2, taking complement of that. Okay. So, by De Morgan's theorem, this is m 0 prime ANDed with m 1 prime with ANDed with m 2 prime. Okay. And we have already noted for these Maxterm based representation, the same function f x y z over here, we have noted that this is m 0, capital M 0, capital M 1, capital M 2. So, we can see for any such truth table, if you just extend it, that m I prime, so m 0 prime, m 0, they correspond. So, m I prime is same as a min term ith position. If you take complement of it, you get Maxterm, the corresponding Maxterm in the ith position. This is a very simple relationship we will keep in mind. Okay. Now, given an expression to get the min terms or the Maxterms, right, what we have done, we are getting the truth table, and from the truth table we are looking at the xyz or xy whatever the input variable combinations, and wherever there are ones we are getting min terms for those combinations and writing it in a particular manner, and similarly for Maxterm. So, this is one way we can get all the min terms and Maxterms of a particular Boolean expression. It can be obtained algebraically also, okay, without going via the truth table route. So, for example, this x plus x prime y is there, okay, and we want to get its this particular terms min terms, that means all the different things that are there. So, x you can write as y plus y prime is the from complementarity, this x is x ANDed with 1. So, 1 can be written as y plus y prime. Then if you just expand it, that is AND x y with x with y and x with y prime, then you get this 3. So, this is the all the contents, all the literals, all the variables. So, these 3 min terms that you get. Okay. So, you do not need to go in that direction. So, similarly for the other problem, POS problem. So, x plus y you can write as x plus y z z prime. Complementarity is just summing up with 0, ORing with 0, it does not make any difference in the final outcome. So, x plus z you can write as y plus y prime. Then you can use distributive law. So, this x plus y, z will be coming here and z prime will be coming here. And in the other case, x plus z is one thing and y prime. So, y will be coming here and y prime will be coming in the other place. Then you can see x plus y plus z are there in 3 places, x plus y plus z are there in 2 places. So, keep one of them, and these are the 3 Maxterms that you are getting, that is m 0, 1, 2. Okay. So, algebraically also you can arrive at the Maxterms. Okay. Now, implementation of this canonical form is very standard. So, SOP form. So, just look at just one example. So, in this case, we will be having a AND bank followed by a OR gate. So, this is a example where M Minterms 3, 5, 6, 7. Okay. So, they are getting ORed, okay, in the final summed up in the final function output. So, M3 is A bar B C, right, A B C, 3 is 0 1 1. Okay. So, A bar B C is one input generating one minterm, 5 is generated in the by this, 6 is generated by A B C prime and 7 is generated by A B C. Okay. And finally, all of them are OR and you get a SOP realization of this. This is called two level, okay, assuming that the variables are available both in complement and uncomplemented form. So, both A and A bar, they are available at the input side. Otherwise, if it is only A is available, to get A bar you need another NOT gate. Okay. So, in that sense one may think that it will increase another level. Okay. But the assumption over here is that both A and A bar are available simultaneously at the input side, and these are the two levels, one AND bank followed by a OR gate, okay, which is required for this two level implementation of the canonical form of SOP. Okay. For POS it is similar. So, there will be OR bank followed by a multi input AND gate depending on how many OR gates are there. Okay. So, practical issues, as I have mentioned before, the fan in, fan out, all those things need to be considered. If it is violated, we have to take other measure by which we see that things are in order. So, here it is 0, 3, 6, right. 0 means A plus B plus C. So, this is your A plus B plus C. Okay. So, 3 is your A plus B bar plus C bar, right. This is okay. So, 0, as we have noted, 0 0 0. So, whenever 0 is there, it will go uncomplemented for Maxterm generation. So, finally, 6 is A bar plus B bar plus C, that is your 6. So, all of them, these outputs are summed and ANDed, and we get the final output. So, this is also a two level implementation. And what could be multi level implementation? So, here is just an example of a 3 level implementation, right. So, A, B, C, D is ANDed with E plus E and F, the summation of E and F. So, E and F are summed up, then this is there. So, you can see 3 stages are there, right. So, this is a 3 level implementation. You could have made a 2 level implementation by expanding it D, E, I mean just ANDing it following the distributive law and D, F. So, this would have given you a 2 level, implementation. Okay. So, we can use NAND and NOR based 2 level circuit for realization of SOP and POS form respectively. This is useful in certain sense that it uses only one variety of gates, okay. And this is evident from this particular relationship what has been shown here for say A, B, C, D and E, F. This is a SOP realization. So, in this case you can take double complement of it, and then from De Morgan's theorem you can see that this A B becomes A B prime, that is your NAND operation over here, and this is NAND operation of C D, NAND operation of E F, and ultimately all of them each individual NAND output are ANDed and complemented. That means, another NAND operation is involved in the last stage, the second stage, second level, and you get the same SOP instead of AND and OR, that is this, you are having a NAND replacing the AND bank and another NAND replacing the OR gate, the final OR gate. Okay. So, by this you are getting only one variety, using only one variety of gates. So, here is an example So, here you see the M3 this is the Minterms that are getting summed. This is using the canonical form. It can be used for other form as well, any form like what I had shown as an example. So, basically Minterms 3 is your A bar, B and C. So, you see this output here it is A bar, B and C. So, that is the corresponding NAND term will be generated, and then that NAND term is finally again with other NAND gate outputs, another NAND gate is formed, and then you get the same SOP realization, but using NAND implementation. Okay. And here in this example we are showing the corresponding IC numbers, 3 input 4 input IC numbers, the 7410, 7420, and you remember for 2 input NAND gate it is 7400. Okay. So, that we have seen before. The same thing goes for POS representation using NOR gates, and in this case again similarly the original expressions AB plus CD plus EF, any such example you can take up. So, this is OR gates, OR banks in the beginning, which is ANDed in the final stage, second level. Okay. In that case again you are taking double complement, and then you are taking using De Morgan's theorem. So, this is one NOR gate, this is another NOR gate, this is another NOR gate, finally a 3 input NOR gate combines all of them and you get a NOR level representation. So, similarly for this particular example we have one NOR bank followed by another final NOR output stage, and we can get the same result. Okay. So, to end we just take note of one interesting aspect of the circuit level realization. So, actual electronic circuit that we are using, it is just a it is an entity which is just taking up some input voltage and generating some output voltage. So, for example, an electronic circuit which takes up A and B as input, the input to is a digital electronic switching is involved. So, input is only logic only voltage level high or voltage level low. So, these are the two cases that are there. So, basically it is high or low, that is you are sending. So, this is low and this is high. Okay. And the corresponding output is also generated, which is either low or this is high. So, this is also similar the possibilities, right. And the circuit that we are having has got this characteristic. So, if input is low and low, the output voltage is also low. Input is low and high, output voltage is high. High and low, this output voltage is high, and high, this output voltage is high. Okay. So, if we consider high voltage as 1, binary value 1, and low voltage as binary value as 0, okay, then we can get this can be converted to a table like this: 0 0, low low, 0 0, output is 0, low high, 0 1, output is 1, and so on and so forth. Okay. And corresponding the truth table that we get is that of OR operation, OR logic operation, isn't it? So, when high is associated with 1, high voltage is associated with 1 and low voltage is associated with 0, we say that what we are following is called is positive logic. In our discussion now, before, now and in future also, we will primarily deal with positive logic, okay. But we need to take note of negative logic, and we may use it as it if such occasion arises. Okay. So, in negative logic what happens? It is just opposite of it. So, a high voltage is treated as logic low, and a low voltage high voltage is treated as binary value 0 or logic false, and low voltage is treated as binary value 1 or true. Okay. So, in that case the low low becomes 1 1, okay, because low is 1 and low this is 1. So, low high is 1 0, and the output is high means here high voltage means binary value 0. So, this is 0. So, then 0 1 0 0 0 0. So, if you just look at this table, okay, we can see that it matches with AND truth table. Only thing is that 1 1 is written in the beginning. It does not matter. Truth table, all possible combinations we are talking about, whether you write 0 0 in the top or 1 1 in the top, the meaning and significance remains the same. So, same electronic circuit, the box that you see here, which generates a high or low voltage depending on the low and high voltage is presented at the input, we get the corresponding these values. Okay. So, the same circuit is positive OR gate and negative AND gate. Okay. So, the same way for any other circuit you can see there is a interconnection. The same circuit which we can treat as positive OR and NOR gate following negative logic, this notation, okay, this understanding, we can have equivalent AND, OR, NOR and NAND gates. So, basically this is the thing that you can get. Okay. So, this we shall keep in mind, and if we required we can make use of it in our analysis. So, with this we conclude that taking out of Minterms, canonical SOP form can be obtained, and taking AND of it we can get POS form, and the max terms and min terms can be obtained from truth table as well as by algebraic manipulation of a Boolean expression, and the canonical form can be converted from one form to another, and two level SOP realization can be done through AND OR as well as NAND NAND, and POS realization can be done through OR AND as well as NOR NOR, and same hardware can provide negative logic based realization with an alternate interpretation of high and low voltages. Thank you.